plus 16. So Laplace transform of given function is, we write here, therefore Laplace transform of given equation is 4 divided by s into s plus 3 square plus 16. Now second problem. So what is given? Given is x of t is equal to e raised to minus 4t u of t into e raised to minus 2t u of t. Now convolution becomes multiplication in Laplace domain. We write here. Now here convolution is given. So convolution becomes multiplication in Laplace domain. Therefore x of s is equal to Laplace of e raised to minus 4t a of t into Laplace of e raised to minus 2t u of t. So now we have standard formula. So it is Laplace of e raised to minus at u of t. Standard formula for this is 1 by s plus a. So we can write above equation as x of s is equal to one by, it is u of t, 1 by s plus 4 into 1 by s plus 2. That is, we can write 1 by s plus 4 into s plus 2. So this problem was asked for 6 marks in previous exam. Now next problem. A signal x of t has Laplace transform. X is equal to s plus 1 divided by s square plus 4s plus 5. So find Laplace transform of first one, y1 of t is equal to x of t, and second, y2 of t is equal to e raised to minus t x of t. So the problem was asked for 6 marks. So first one, Now here we have to use the differentiation property. So we write according to differentiation in S domain property. According to differentiation in S domain property, we can write minus t x of t, its Laplace is e raised to minus st0 x of s. Therefore minus t x of t Laplace, it is minus d by dt of s plus 1 divided by s square 4s plus 5. Therefore Laplace of t of x of t, it is minus of s square plus 4s plus 5 into d by dt of s plus 1 minus s plus 1 into d by dt of s square plus 4s plus 5 divided by s square plus 4s plus 5 square. So we have to solve it now. So it is minus of s square plus 4s plus 5 into 1, derivative of s is 1 and this one is constant, into s plus 1 into 2s plus 4 divided by s square plus 4s plus 5 square. So we solve this equation, that is multiply, and we get final answer. Here I directly write final answer. After solving we get s square plus 2s minus 1 divided by s square plus 4s plus 5 bracket square. This is Laplace of x of t. So the second problem, now here we have to use the frequency shifting property. So we write according to frequency shifting property, e raised to s0 t x of t, it is x of s minus s0. Now here s0 is minus 1. Therefore e raised to minus t x of t, it is x of s minus plus 1. So it is s plus 1 plus divided by s plus 1 square plus 4 into s plus 1 plus 5. Therefore x of s plus 1 is equal to s plus 2 divided by s square plus 2s plus 1. We just solve it. Solve this bracket, 4s plus 4 plus 5. So final answer is 2 plus s divided by s square plus 6s plus 10. So this is the answer of it. So here we use the frequency shifting property. Next problem. Find Laplace transform of given figure. So the given figure is it is t, it is x of t 0, 1, 2, 1 and 2. So we have to find out the Laplace transform of this figure. So for that, first step is step 1. X of t is equal to u of t plus u of t minus 1 minus 2u of t minus 2. So here we can draw the separate diagram for each term and then we can perform the algebraic operations. Okay. Now step 2 is Laplace of x of t is equal to x of s. So Laplace of x of t minus a, it is e raised to minus as x of s. So for x of t, it is u of t plus u of t minus 1 minus 2u of t minus 2. So Laplace of what is u of t minus 1 is t minus 1, it is e raised to minus s 1 by s, and Laplace of minus 2u of t minus 2, it is minus 2 e raised to minus 2s into 1 by s, that is 2 e raised to minus 2s by s. Therefore xs is equal to 1 by s plus, we just add all these terms, so 1 by s is common, taken outside the bracket, 1 plus e raised to minus s plus, not plus, it is minus 2 e raised to minus 2 s. So this is the answer of, that is, this is the Laplace transform of the given figure. Now the next problem. Find Laplace transform of given figure. The figure is, it is t 1, 2, 3, it is 1 and 2. So we write down the solution here. So x of t is equal to u of t plus u of t minus 1 minus u of t minus 2 minus u of t minus 3. So Laplace of u of t, here we separately write the Laplace of all these terms. Laplace of u of t minus 1 is e raised to minus s by s. Laplace of u of t minus of t minus 2 is e raised to minus 2s by s, and Laplace of minus of u of t minus 3 is e raised to minus 3s by s. So we just add all these terms. Therefore x of s is equal to 1 by s plus 1 by s e raised to minus s plus 1 sorry not plus, it is minus of e raised to minus 2s by s minus e raised to minus 3s by s. Now next problem, find Laplace of the Laplace transform x of t of given figure. So the figure given is, it is t 0 1 2 3, it is 1 and 2. So step 1, x of t is equal to r of t minus r of t minus 1 plus u of t minus 2 minus 2u of t minus 3. So next step 2. Step 2 is we have to write differently the Laplace of all these terms. Laplace of r of t is 1 by s square. Laplace of r of t minus 1 is 1 by s square into e raised to minus s, and it is t minus 2 is, its Laplace is 1 by s e raised to minus 2s, and Laplace of minus 2 of u of t minus 3 is minus 2 by s e raised to minus 3s. So we just add all these terms. So x of s is equal to 1 by s square minus 1 by s square plus e raised to minus 2s by s Now next problem, obtain Laplace transform of the given figure. It is t 0 1 2, it is 1. So for the given waveform we can write the mathematical equation as x of t is equal to r of t minus r of t minus 1 minus u of t minus 2. So we separately write the Laplace transform of r of t. It is 1 by s square. Laplace transform of r of t minus 1. It is 1 by s square into e raised to minus s. Laplace of u of t is 1 by s, and Laplace of u of t minus 2 is e raised to minus 2s by s. So we add all these terms. X of s is equal to 1 by s square, 1 by s square into e raised to minus s minus 1 by s e raised to minus 2s. So this problem was asked in exam. So the next problem, find Laplace transform of figure it is t 0 1 2 3 4 and it is 1 and 2. It is x of t. So first is we will write the equation for this diagram. X of t is equal to r of t minus 2r of t minus 1 plus r of t minus 2 plus u of t minus 2 minus u of t minus 3. So here I directly write the answer, that is x of s, Laplace of all these, Laplace of r of t is we already calculated, it is 1 by s square. Next is minus 2 by s square e raised to minus s, t minus 2 it is 1 by s square e raised to minus 2s plus 1 by s e raised to minus 2s, 1 by s e raised to minus 3s. Now the next problem, find Laplace transform of the given waveform of the given figure. So diagram given here is, it is t 0 a, that is 2a, it is 1 x of t, so here step 1, first we write the given, here given waveform is periodic, we write here given waveform is periodic. So for a single sawtooth function is x of t is equal to r of t minus r of t minus a minus u of t minus a. Then second step is its Laplace. So we'll take Laplace is xs is equal to r of t Laplace is 1 by s square minus 1 by s square e raised to minus as minus 1 by s e raised to minus as. Next is step 3. So here step 3 is Laplace of periodic waveform is Laplace of periodic waveform is, so here we draw it, it is t 0 a, this is 1, it is x of t, so this is single period. So x of s is equal to x1 of s 1 minus e raised to minus t0 s, where t0 is periodic and here t0 is equal to a. So equation is x1 of s is equal to 1 by s square minus 1 by s square e raised to minus as minus 1 by s e raised to minus as divided by 1 minus e raised to minus as. So this is the Laplace of the given periodic waveform. Next problem, find the Laplace transform of periodic wave. So here waveform is, it is t, it is plus 1 and it is minus 1. The function is x of t 1, 2 and 3. So first we write step 1 is x1 of t for one period of given waveform. We will draw here. For one period we draw the waveform which is named as x1 of t. This is for one period. One period means one complete cycle. So it is plus 1, it is minus 1. So this is one complete cycle, that is one period. So we write down the equation for this as x1 of t is equal to u of t minus 2u of t minus 1 plus u of t minus 2. Now second step is Laplace. So we write down its Laplace is, here we directly write Laplace of x1 of t, so it is equal to 1 by s minus 2 by s e raised to minus s plus 1 by s e raised to minus 2s. Now next is step 3. So step 3 is Laplace of periodic waveform. Right here, Laplace of periodic wave of period t0 is equal to 2. So equation is x of s is equal to 1 by minus e raised to minus 2s, 1 by s minus 2 by s e raised to minus s by s e raised to minus 2s. So this is the equation. First we draw the diagram for one period of the given waveform. Now next problem. Find the Laplace of Laplace transform of given periodic signal. This problem was asked in exam for 6 marks. So the given signal is, it is t 1 2 3 4 5 6 7 8 and so on, and it is here, it is 1 and 2. The signal is x of t. So this is the diagram. Now first is step 1. So step 1 is x of t is given as, so we can write x of t function u of t plus u of t minus 1 minus 2 u of t minus 2. So for one wave only, call it as x1 of t. So first we draw the x1 of t only, that is for a single wave. So it is t 0 1 and 2. It is 1 and 2. It is x1 of t. This is single wave. So period for here, period t0 is 3. Now step 2, Laplace of x1 of t. So it is, here I directly write down, it is 1 by s plus 1 by s e raised to minus s minus 2 by s e raised to minus 2s. So next is step 3, Laplace of given periodic wave. So here xs is equal to x1 of s divided by 1 minus ts. So we have the value of x1 of s, we just replace it. Divided by 1 minus e raised to 3s. So this is the answer. The problem was asked for 6 mark in exam, university exam. First we calculate for one wave only, that is for x1 of t, and then we calculate for total wave or all the waves. Next, find Laplace transform of the given figure. So here diagram is given. It is t 0 to pi, 2 pi and 3 pi. So from this figure we can write x of t is equal to a sine of t. This is for t is in between 0 to pi, and this value is 0 for if t is in between pi and 2 pi. Okay, so since Laplace of x of t is integration 0 to t0 x of t e raised to minus st dt divided by 1 minus e raised to minus st0. This is periodicity property. This is periodicity property. So which is equal to 0 to pi a sine of t e raised to minus st dt divided by 1 minus e raised to minus st0. So we take the integration, it is a divided by minus e raised to minus t0 integration 0 to pi e raised to jt minus e raised to minus jt divided by 2j e raised to minus st dt. Since what is the value of sine theta? Sine theta is e raised to j theta minus e raised to minus j theta divided by 2j. So we write here it is equal to a divided by 2j is constant, 1 minus e raised to minus at0. So here integration 0 to pi e raised to j minus s into dt minus integration 0 to pi e raised to minus into bracket j plus s dt. So we solve this and here I directly write the answer. By solving we get e raised to j pi into e raised to minus s pi divided by j minus s minus 1 by j minus s plus e raised to minus j pi into e raised to minus s pi. We take the integration and replace these integration values, and after that we get this equation j plus s minus 1 by j plus s. But e raised to j pi, this value is 1, and e raised to minus j pi, this value is minus 1. So we substitute these values in this equation and we get x of s, that is Laplace of this, is a by s square plus 1 into 1 plus e raised to minus s pi divided by 1 minus e raised to minus s t 0. We substitute these values in this equation and we solve it, and we get the final answer. So this is nothing but the Laplace transform of half wave rectified periodic signal. So we can find full wave rectified signal also in the same manner. So this problem was asked in exam for 10 marks. We have to replace these values here and then solve it.